All right, let's look at question number 3. It's a Diffy Q. And see how many points and understand. Maybe it's been a while since we looked at a Diffy Q. So there's a slope field. It's shown here. And it says just sketch the solution curve through 0, 5. So I'm going to start here at 0, 5. I'm going to follow the slopes and draw the picture. So I'm just going to follow the slopes and draw the picture. Notice as it's rising up to the right, it's flattening out. You see this horizontal slope right there. It's going to flatten out right with that horizontal slope. Actually creates a horizontal asymptote. And it shows the end behavior. Here it is. That will give you a point. Done. Part B. That was it. We're going to do this on the piece of paper on the left so that you have room, okay? So it says use the line tangent to that at t equals 0 to approximate. So can you do a tangent line? Sure you can. So in part B, it says t equals 0. So I need to know the y value. So m at 0. So at t equals 0, m is the temperature. So the temperature of the milk is 5 degrees. And then I need to know the slope at 0. To know the slope at 0, we have a derivative for m. It's given right in there. What's the slope there? So there's the derivative. 1/4 40 minus m. That's the derivative. Plug in 0 in here, and I get 10. Right, 1/4 times 40, got 10. And then what the equation would look like. If you use x, it's okay, but they use the letter t. So the slope is 10, and then it's t minus 0. And then plus 5. So that's really just this. Then it says, use the line tangent to the graph at 0. So that's what we did. T is 0. At 0, that's the temperature. That's the slope at 0, which is 10. And then it says approximate the temperature at t equals 2 using that. So if I use that, the approximate temperature of it is 10 times 2 plus 5. So the approximate temperature at 2 is 25 degrees. We can do that. Wait a second. All right, let me back up. So when I find the slope here, m is actually the y-coordinate. So m for this slope is 5. So I actually should have plugged in 5 here. So the slope at 0, plug in 5, would have given me 35 over 4. My bad. Which make this 35 over 4. Which would make this 35 over 4. So our temperature would be 70 over 4 plus 5 degrees, and I don't have to simplify that. That's like 22.5 or something like that. All good. All right, we're on track. Part C. It says write an expression for the second derivative. So let's write the first derivative again. So the first derivative is 1/4 40 minus m. So the second derivative then would be what? So I'm actually going to distribute this. So 1/4 times 40 is 10, and then 1/4 times negative m is, oh, I can't believe you can't see me. I'm right here, just in case you want to know. 1/4 times big M is that. So I just distributed. And then what's the derivative of that? So the derivative of 10, that's 0. The derivative of negative a quarter m, this has to be done implicitly, is negative a quarter, but it has the hook dm by dt. So that means that I replace dm by dt with what it's equal to, which is right here, 10 minus 1/4 m, and that is the second derivative. Then it says, is it a over or underestimate at m at 2? So to know if it's an over or underestimate at 2, I need to know what the concavity is. I need to know at 2, is the answer positive or negative? So I have negative 1/4. I have 10 minus 1/4 times 2. And if I simplify that, you can see that that answer, and I don't have to simplify it further, right? You can see that answer is less than 0, which means it's concave down. So if something is concave down and you have a tangent line on something concave down, that tangent line is above, which makes it a overestimate. So the question is, m at 2 is an overestimate, since it is an overestimate since it is concave down at t equals 2. So this shows it's concave down. When it's concave down and a tangent line, the line is above. Just so you know, if it was concave up in a line, you'd see the line is below. That would be an underestimate. All right, part D. This is where we get all our money right here. Can I solve this Diffy Q? So the two variables are m and t. So if I want to solve this Diffy Q, I need to separate. So to separate it, the m's on one side and the t's on the other side. So I'm going to divide by 40 minus m. I'm going to multiply by dt. That would give you a point. I'm going to integrate this. This is a logarithm. The derivative of the bottom is negative 1, so it needs to be negative, but that's it. So it's negative ln 40 minus m. The antiderivative of 1/4 dt is 1/4 t and then plus c. Then we're going to plug in the point, which is 0, 5. So m is 5 and t is 0, and I'm going to solve for c. So you can see that c is negative ln 35. That would give you another point. Okay, we're doing okay. Then I take that answer and go back and plug it in. So it's negative ln 40 minus m 1/4 t minus ln, and the absolute value of 35 is 35, so it's just that. So then I plug it in. Then I need to solve for m. So to solve for m, I'm going to multiply everything by negative 1. So I'm just going to change the sign. So multiply everything by negative 1. That's negative 1/4 plus ln 35. Then, to solve a logarithmic equation, I write it exponentially. So what's inside the bars is 40 minus m, and then e to the exponent, and all of this is there. Again, my goal is to get m by itself. So I'm actually going to add m, and I'm going to subtract this e to all of that. And that's perfect. And you have now solved that Diffy Q by getting m by itself. All right, Mr. G Math over and out. I'm proud of you because what's happening? We are not giving up. Where is it? No, not giving up today. Right? Is that what it says? No. Oh, not giving up. Giving up's not an option. That's what it is. That's it. Not an option. All right. See you later. And I'm proud of you. Trying your best.